All right. So this is Precision Agriculture Incubation Program. So the practical is taking place at the Federal University of Agriculture in Abeokuta, FUNAM, Ogun State, Nigeria. And we're taking 2 days, 26th and 27th of November. That's Tuesday and Wednesday. So now it's turning to Thursday anymore. So part of things you start to gain in registering for the on-site is that you will get a copy of the Drone Professional 3 book, co-authored by Mr. Femi Adekoya, a vision lead. This book is actually rich because it's a compendium of the best current thinking of various drone professionals in various career space, in agriculture, in mining, security, healthcare, yeah, just different career spaces. So this will really give you exposition into the reality of drone technology and how it's relevant in the future of work. So also you are going to get hands-on training on the simulation. This is just like a computer-based training to prepare you for the real drone flight experience. So after that, you get to learn on the field how to actually fly a drone, replicating some of the things you've learned in the simulation CBT training in the real life. So also you're going to get a certificate after this program endorsed by International Society for Precision Agriculture, ISPA, and other partners, Integrated Air Precision, DevAfrica, DevGlobal, and others. So you're also going to learn about the act of aerial drone mapping. That's for geospatial application, 2D mapping, 3D mapping, how we can actually map, doing orthophotos, then processing it into actionable data and insight that actually make meaning. You're going to witness how a sprayer drone actually works. So beyond just the knapsack sprayer, drones can actually spray efficiently, saving time and saving cost, and ultimately preventing farmers from exposure to chemicals. Yes, so drones can easily get the job done. We're also going to be joining a team to actually build a fixed wing drone like this for large scale mapping of surveillance area. So this is part of what we're going to be doing, the practical section at the lab. And lastly, you need to put your best foot forward. So Integrated Air Precision, a partner, will also be giving internship opportunity to about 10 students. So if you actually put your best foot forward and you do excellently well, so this can actually fetch you an internship opportunity. Yeah. So that's just it basically. Let me quickly talk about Precision Field Academy. So Precision Field Academy is a digital agriculture training school, and vision at Precision Field Academy is to create a world where every young person, regardless of their background, has the opportunity to become a digitally savvy farmer and agricultural professional, driving sustainable and equitable growth in their community through the transformative power of technology. And our mission is to raise the next generation of farmers that are tech inclined and digitally savvy. So about Precision Field Academy, it's more like a social enterprise where we train and build the capacity of youths and young professionals in modern and emerging technology for the future of work and also to lead with precision agriculture. So we have core three methodologies: education and knowledge sharing, training and skill development, coaching and mentorship. And aside these three methodologies, we have six tech skill in focus. Number one is drone technology. We are harnessing the power of drone technology to collect data and help farmers make informed decisions about farming practices. And also we have GIS and remote sensing, geographical information system and remote sensing. This talks about area of data in remote sensing using satellite imagery and also drones and every other uh, geospatial technologies to actually collect data uh, to enhance farming practices. We have data science in agriculture. This is revolves around collection of data in different phases. We maybe plant health, plant cultivation, yield estimation, want to do plant count, uh, crop nutrient deficiency, and yeah, various kinds of data like that. This is in association with data science in agriculture. And we have a course at Precision Field Academy called the Phyto Mapping Masterclass. This is strictly for agronomists or plant physiologists or farm managers who are actually interested in understanding the reality of the farmland. So this will give you the capability to be able to understand the in details multispectral sensors, thermal sensor, hyperspectral sensor. What is the application in agriculture? What kind of data can they help you to get beyond the RGB cameras and drones for visual protection? So outside this, we also have Internet of Things and robotics. We had some classes recently talking about smart digital technologies for livestock farming in cattle, poultry, and also for precision farming. That's talking about smart irrigation system, whereby these devices have the capability to detect the water content in the soil, then triggers the irrigation system to actually irrigate the farm, even while you are not there. So it works on its own due to pre-instruction given through a microcontroller or a computer system. So outside this, also we have artificial intelligence and machine learning. Yeah, we're looking into artificial intelligence and machine learning, how we can leverage this technology to help farmers enhance their farming practices, uh, get entangled with accurate data that can really help them to make precise and accurate decision, helping them to save time, save cost, and also farming efficiently. And lastly, we have enterprise development. Enterprise development here is that our goal is for us to actually raise more young leaders in precision agriculture, creating enterprise focusing on agri-tech solution, uh, platforms whereby you talk about data collection. It could be in satellite imagery, using drones, using other intelligent machines in aspect of robotics, machine learning and Internet of Things. It could also be using Earth observation systems, GIS, and all of this thing. Yeah. So because this is actually the future of work in agriculture, and for us to relevant in this field, yeah, it's important we build the technical skill. So what's our motivation for doing this? We've discovered that there's a skill gap that needs to be closed, and young professionals need to build skills on both technical and enterprise skill, even including soft skill, for the future of work in agriculture. So observing the trend is not enough. So young people who are youths need to be an enabler and a player in the fourth agricultural revolution, and not just mere observer. So this is about direct inclusion. So number three is that technology is actually the key to unlock the potential of African agriculture. So we can ride on the wing of technology to enhance African agriculture landscape. So why should you join us? We are creating the future we want in agriculture, and we beckon on you to actually join us. So we also connect you to the world of information and world of opportunities. This comes in terms of scholarship, internship opportunity, volunteership opportunities, which comes both local and international scale for your career growth. Besides this, we also share with skill development through project collaboration, community interaction, and workshops, university workshops, symposiums, and seminars. And lastly, you have access to coaching and mentorship from our industry leaders and global professionals. So at Precision Field Academy, we are committed to building a community of young tech inclined and digitally savvy farmers and professionals. So let's get to today's work. All right, so today we are going to be talking in details about introduction to sustainable and data-driven agriculture, in quotes, data science. And our speaker for today is Dr. Joseph Miango. He's a senior lecturer of applied data science at the Upper Adams University in United Kingdom. So I will quickly need to read through his profile. All right. So Dr. Joseph Miango is currently active in the field of proximal and remote sensing for precision agriculture, where he leveraged big data for satellite imagery, unmanned aerial vehicles, and proximal soil sensors to generate prediction models for decision support in agriculture. His research interests include through eye through fruit plant through plant phenotyping and the use of deep learning method for automating perception tasks in agriculture. His previous background includes 8 years of experience in agricultural production management, input and output marketing, research and development within the framework of the consultative group of international agricultural researchers. He is presently a senior lecturer of applied data science at the Upper Adams University, United Kingdom. Uh, okay, let me bring him to the stage. Hello, sir. Dr. Joseph, you're welcome to the stage, sir. If you can hear me.
I can hear you, Joseph. Can you hear me?
Yes, yes, I can hear you very well, sir.
Perfect.
Okay,
Thank you
you have
very much.
it, so you can probably share your screen. All right, sir.
I'm just sharing my screen now.
Okay, sir. Once it's up, I'll bring it instead. Okay. Okay, your screen is actually on. I can see introduction to sustainable and data-driven ag with your by data. So you can do how to switch to slideshow so we can get started. So
I have a slideshow. Um, Not sure why it's not on slideshow on your end. So let me just try and stop the screen, put myself in slideshow, and then share again.
again, okay, all right, that's fine. Okay, I think we're good now. Yes, it's
Okay,
fine. It's fine. Yeah.
perfect. All right. Thank you very much. So,
Yes, sir. You're welcome, sir. It's really good to have you.
thank you. It's good to be here as well. As I have already been introduced, my name is Joseph Muhango. I'm a senior lecturer in applied data science at Harper Adams University in the United Kingdom. So, the talk for today is about an introduction to sustainable and data-driven agriculture. Um, this is quite a loaded subject, so I have tried to distill it into some smart, shareable concepts that we can talk about today. And hopefully, at the end of it, you will have been motivated to understand the role of data science in this big term that we call sustainable agriculture. So, why don't we start with defining what sustainable agriculture is? Um, there are so many ways that this term is defined. There isn't an agreed universal definition for what sustainable agriculture is. Um, but the closest that we can get to, in my opinion, is the definition by the United Nations Food and Agriculture Organization. It defines what agriculture needs to be in order for it to be sustainable. Um, Sustainable agriculture must meet the needs of the present and future generations while ensuring profitability, environmental health, and social and economic equity. So there are three dimensions there. There is the environmental sustainability, there is social sustainability, there is economic sustainability. The way you would understand this is environmental sustainability means that our agriculture should be environmentally friendly. Social sustainability also means for agriculture to be sustainable, it has to operate within the social context. So you have to take note of what people's culture is, what they are likely going to eat, what they will not eat. You cannot bring some socially insensitive agricultural practices to a community and expect them to be sustainable. They will not survive. And number three is economic sustainability. Well, that's pretty much self explanatory. For agriculture to be sustainable, it has to make economic sense. Otherwise, people are going to move into other means of earning a living. So, those are the three dimensions of sustainability. So, everything we discuss must be within this framework. Um, the key principles that have been identified by the FAO are five. First, we must increase productivity, employment, and value addition in food systems. And secondly, we must enhance the resilience of people, communities, and ecosystems. And thirdly, we must protect and enhance natural resources. And we must also improve livelihoods and foster inclusive economic growth. And finally, we must adapt governance to new challenges. So, the way that I would want to discuss the role of data science in this is by just going through each of these five and seeing where data science comes into play. Because if we can do that, then we have defined the role of data science in sustainable agriculture. And that pretty much covers our topic because our topic is the introduction to sustainable agriculture, in quotes, data science. So um, we will attempt to do that over the next few minutes. And hopefully at the end of it will be very clear to you if this is new to you, what the role of data science is in sustainable agriculture. So let's jump into it. We will start with the increasing of productivity, employment, and value addition in food systems. Um, I came across this picture and I put it here to say um, how much can data science carry? And data science, as um, defined, is a mixture of computer science, statistics, and subject matter expertise. When you mix these three things together, computer science, statistics, subject matter expertise, you pretty much come up with what a data scientist is. A data scientist is not a computer scientist, but a data scientist knows a lot about how computers handle data. A data scientist is not a pure statistician, but a data scientist will know the compendium of statistical analysis techniques that are amenable to real world problems. A data scientist um, has to be a subject matter expert to have the expertise to solve problems because data scientists by nature are responsible for problem solving, and that is their role. So, this made me think about for agriculture uh, something that is happening that you will see in the next slide. But that thing that is happening is similar to what cell phones have done over the years. We used to have, we used to listen to music through uh, the radio, through Walkmans, through a lot of devices. These days, we do that through a cell phone. Our clocks are in cell phones. Our video cameras are in cell phones. Our newspapers are in cell phones. Our libraries, our telephones, our video games, our own cabinets that we keep books in is the cell phone. We use cell phones for uh, as our guides. We don't need a tour guide anymore. These days, we use cell phones to take us anywhere we want. We have maps on the cell phones full with automated navigation. Um, we use our cell phones as mirrors when you don't have one. You take a selfie and look at how you look. We use our cell phones. There was something interesting. Somebody said cell phones are the new cigarettes because they are what you use to pass time and relieve tension these days, which is why most people smoke. They smoke to relieve themselves of tension. And these days, many people are addicted to memes and TikToks and all of that. When you're stressed at work, you take a little bit of a break. Instead of going to smoke a cigarette, you're going on TikTok. And now that has become the new addiction. So cell phones have taken over our lives in many ways. I wanted to give that same analogy to the role of drones in agriculture. Drones are on that trajectory of a cell phone, but on a farm. Increasingly, drones are doing a lot of what you and I would have done manually not too long ago. Most of what people still do manually, a drone can do. And that is the first role of data science and productivity. To sort of make that point clear, I have this slide. The picture on the right shows you the sort of things that drones are already doing right now. There would have been a time when people would have held up uh, this device here to sort of um, understand stomatoconductance if they're doing agricultural experimentation on a research farm and use that to understand how drought works in certain plants. Well, drones can do that now. If you have a thermal drone, it will tell you exactly that it takes a bit of data science, but you can be able to model uh, evapotranspiration. Well, the transpiration part of evapotranspiration using thermal cameras. Um, Years ago, it still happens. Someone would have used a SPAD meter to estimate the amount of nitrogen in leaves. On a research farm, in your field, many farmers in the West do it. In Africa, you go and look at your leaves and see how green they are and decide whether your crop is good or not. You pretty much use your eyes. Drones can do that now for you. Multispectral drones, multispectral cameras on drones will allow you to use data science techniques to model how nitrogen is spread out in your field. The same goes with leaf area index. Many people will use a septometer, this little instrument over here, to calculate leaf area index. If you're an agriculturist, you pretty much probably understand this. Drones will help you do that now by a mixture of plant height and ground cover. You can estimate leaf area index with sufficient accuracy for you to make decisions on. And this one is for ground cover. People would have used an app on a cell phone. People would have used a grid like this to estimate the percentage of ground that their crops have covered. We do that with drones now. We use drones to estimate plant height in our crops instead of using rulers. So as you can see, this humble little device that we call a drone that is getting smaller every minute packs a lot of heat. It can do all these things. And these are the sensors um, that we get in crop production. And this thing is loved because it is very high resolution. But if you can deal with lower resolution, there are satellites that can also do a lot of this. A lot of this can be done by satellite as well. Maybe except plant height, but still, we're getting there. And all these sensors are amenable to data science techniques. All these sensors collect data, but the person who will draw out all these insights is the data scientist. So you can have all this data, and there are a lot of people that collect data using drones, but not many people know how to generate the insights they want from that data. So people end up just sharing pretty pictures and maps. But the jump from having a very cool gadget to being a very useful professional in your field, the bridge is data science. And that's the first bit that data science has a role in here. If you want to model how crops grow and therefore increase productivity, you have to have a mixture of data science expertise and access to sensors like drones and satellites. And all of this is meant to optimize crop yield. Secondly, um, well, like I said, satellites are also able to operate in this field and produce for us maps that are at field scale, that are at a regional scale, that are at a continental scale. But a satellite will also just take pictures, normal RGB pictures or multispectral reflectance data. And the data scientist will turn those pictures into maps that can span from a single field from 10 meters only all the way to the entire Africa. And only a data scientist will have the skills to do that because it takes a mixture of computer science to help you crunch all this data and move gigabytes of data very efficiently, extract the sort of features that you want from these gigabytes of data, and engineer features from whatever you've extracted, and then produce statistical models. And those statistical models must make sense because you have the subject matter expertise to understand what you need to model evapotranspiration or to model crop growth or to model ground cover. So data science is the link between having fancy sensors and making fancy models that people can actually use. What about in animal science? We've talked about crop production. In animal science, for increasing productivity, animal scientists are interested in animal welfare. They want to understand, for example, the way temperatures change in a chicken shed, for example, or in a pen of cattle, how temperature changes because temperature will affect, uh, will cause animal stress if it's too high. And when animals are stressed, they're going to hyperventilate if it's too hot. And that has a problem if you want to produce more, for example, more milk if you're working with dairy cattle. And um, animal scientists are also interested in carbon monoxide monitoring because you want to too much carbon monoxide can actually be very detrimental to the animals, just like it is detrimental to us humans. And that can affect the productivity of your herd, um, and many other things. And in this arena, animal scientists love to uh, have what are known as LoRaWAN sensors. These are normal, for example, temperature sensors or carbon monoxide detectors, very tiny gadgets that you install in your chicken shed or wherever you are growing your animals, rearing your animals. You can put these sensors there and have a LoRaWAN connection. LoRaWAN means long range wireless access network. So these sensors use very tiny packets of data and stream it into the wider internet. It can be a sensor that can operate for years without needing to change batteries. Um, and it doesn't need a strong internet connection. It is a wireless access network that can beam up to 15 kilometers, for example. Um, and then you hook these up onto the wider internet, wherever you have your big router, your big internet connection, or however far it is. And then it beams to the rest of the world. So you can have this and put it in your shed, and it gives you temperature every single second, and you can monitor this temperature. But how are you going to make decisions? You need data scientists to tell you that when temperatures are moving like this every minute, 30 minutes from now, it's going to be too high. So 25 minutes from now, somebody needs to turn on the fan or make an automated system that turns on the fan in this shed to make sure that temperature doesn't go too high. Or now temperature is too low, crank up the heating, or do something. Temperature is too high. We have too much evaporation. Please irrigate these pastures. Irrigate this experiment that I'm growing in a glass house. These are the type of things that these sort of sensors are used for. And for you to make use of these sensors, you need a data scientist to model the data that comes up out of these sensors. So data science, again, is the bridge here. Similarly, if you're looking at productivity, for example, in uh, beef systems, you're interested in daily life weight gain or the flow of milk in dairy cow systems. There are milk flow sensors that people use if they have robotic dairy systems to monitor how much milk they are producing per day. Um, and they monitor that data off-site. And if you have beef systems, you can actually estimate the daily live weight gain by using cameras. You use a camera and you take the dimensions of a cow, you measure the length, width, and torso height of the cow by using simple cameras. The cameras collect all this data. For example, here you get an overhead picture of a cow moving through a narrow passage on your in your farm system. Then you take some pictures and you use those pictures to calibrate um, the width of the cow, the length, the torso depth, and you can use that to predict how much it weighs. So every single day you do this. Um, as the cows are getting out to go and feed themselves, You make a narrow passage that only a single cow can pass through. And at some point, you've placed cameras that are taking pictures of every single cow that goes through. And at the end of the day, every single day, you're weighing your cattle virtually just using cameras. But how do you go from length, width, and depth to weight? That's tricky. No, it is not. Data science will allow you to create models that convert size to weight. And therefore, you can have your productivity data every single day and know how fast your cattle are growing versus how much food they're consuming and against your targets. And you can make improvements based on this information. So that is the other role of data science. Um, all of this feeds into data-driven decision support systems. And these systems can be early warning systems for animal stress, and they can be mechanistic animal models. They can be machine learning models where you build prediction models that then you provide to farmers to say every single day, I'm going to tell you how fast your cattle is growing and what you need to do to reach your targets. If you want these animals to be this big by X date, uh, you're a little bit off. You need to pump up the feed, or they're growing too fast. You're probably wasting your food. Um, you can do that with data science. And the graphs I've put here are examples of this type of work where somebody has put a water sensor and is using the water sensor here to monitor how much water the animals are drinking and has used that to calculate daily live weight gain. And if you plot the two things, they pretty much line up and have a little bit of error here and there, but they pretty much line up such that you can just use this water usage sensor to tell the farmer exactly how fast his chickens are growing. And below here, we have a model that is estimating milk yield by data collected from a camera and some measurements of udder size. And based on that, you can tell the farmer how much milk their cattle is producing. And you can see the estimated milk yield versus the actual milk yield pretty much line up on the one-to-one, apart from random error that you can account for or you can accept the model as accurate enough for you to make decisions. And all of this is made possible by a combination of camera sensors, um, LoRaWAN sensors, and some clever data science in the background to produce these models. Um, there are also early warning systems that get to the level of a continent. So, for example, FuseNet does early warning systems for drought the world over, most of the global south. And they're using remotely sensed data from satellites. They're using crop production data from governments, um, crop production estimate data from governments to sort of predict where drought will be. And governments love this because they use it to plan where to send relief aid, to plan how much aid to seek from outside if they don't have enough resources and they need to reach out to the likes of the UN. They want to have reliable data, but all they have is reliable sensors. So, how do you move from reliable sensors to reliable data about where you're going to have drought? Well, that's where the data scientist comes in. And we can use satellites to predict relative dry weight, for example, as on the graph that I've shared here. So as you can see, data science plays a big role if we are to increase productivity, employment, and value addition in food systems. To meet the needs of present and future generations, we need data driven approaches to appraise the current practices and also to appraise new technologies. So, data science helps us to scale up the hypothesis testing that we used to do in very tiny research plots or your school's research department, those small scale experiments that you used to do using sensor data. You scale them up into the real world and test these hypotheses in real world situations, not highly controlled university sort of researcher managed situations. And sensors have unlocked a wealth of information that before used to be impossible to collect. Like I said, how do you measure, how do you determine the weight of thousands of cattle every single day? You can never do that. Only sensors will help you achieve that. And the data science involved to turn that sensor data into actual insights. So that's about productivity. The second one was the second pillar of sustainable agriculture was enhancing the resilience of people, communities, and ecosystems. So that means we must have ability to monitor how systems are performing. Um, and the way that we do that, first of all, is, for example, FuseNet, which has early warning systems for countrywide crop production estimation. And these types of systems use remote sensing of vegetation growth to sort of predict where drought is likely to occur. And they monitor temperature and greenhouse gas emissions over time, for example, to model climate change and model greenhouse gas emissions and also model drought as well. Um, we can monitor the spatial extents of disasters, and all of this is enabled through remote sensing data. Now, remote sensing data just gives you pretty reflectance data, like I said. But for you to turn that reflectance data into decisions, you use a lot of geospatial data science to achieve that. And geospatial data science, which is the mixture between data science and GIS, geographical information systems, is pretty much where it's at if you want to contribute in this space as a career. Apart from geospatial data science, we also use data science to develop resilient crop varieties. Plant breeders, conventional plant breeding, or anybody who is a plant breeder here will know that plant breeding involves a lot of trial and error. You make crosses between plants and you hope for the best. These days, we're able to sequence sometimes the entire genome of species. And once we have this big genome, when we're able to actually target which genes are related to yield, for example, which genes are related to flower color, which genes are related to whatever it is that we want. And the way we get there again is data science. It's called bioinformatics, where we use genomic data to link genomic data with phenotypes. And the link between these two is bioinformatics. And modern bioinformatics is basically machine learning. It's basically data science. So again, data science is what we're using to build resilient crop varieties that enhance communities and ecosystems to be resilient to weather shocks. And that is the role of data science in this field. At the farm level, at a more non-abstract level for you, there's so many systems that are used as early warning systems, for example, for potato blight, or for armyworm. We all know for armyworm, the big pest that has really disturbed the continent over the past 5 years. Um, we use um, early warning systems to predict where these sort of things are going to happen. There are regional fall armyworm and locust predictions, for example, and they all use weather data. So we have a lot of weather data that we have traditionally only used for weather forecasting to tell whether it's going to rain tomorrow or not. But increasingly, this data is being used to monitor how humidity and temperature changes, and therefore relating it to a conducive environment for fungal spores, and then use that to predict where potato blight is going to occur or where fall armyworms are going to likely hit. And the way that is done is through a lot of very advanced geospatial data science. We have all the weather data that we have been collecting for years, but now we're using this data to predict where fungus is likely to be a problem, and therefore where fungal spores are going to be, and therefore where we're going to have potato blight. And these systems work. For example, we have this map on the right here that has predicted exactly where blight, potato blight, is likely to be a problem just based off weather data. And that is based on uh, data science expertise mixed with subject matter expertise about GIS and about potato blight in its own. And this can be extrapolated to other crops as long as the pathogen behaves in a predictable way based on how weather changes, which is most pathogens in the world behave like that. So, on this pillar, we can confidently say that environmental monitoring of sustainability is heavily reliant on geospatial data science. That's the first thing we can say. And secondly, resilience requires that we are well informed about environmental risks that often start off farm, like disease outbreaks. They often start somewhere else. Um, for example, if you grow cassava, you are likely going to have a cassava mosaic problem because of white flies or because of you having planted cassava material that was grown in an infested area. And diseases spread very predictably based off um, uh, behavior of the phenomena that is attached to the disease. So, for example, the more we share infected cassava material, the more cassava mosaic disease spreads, or the more an area is conducive to the population of whitefly, the more that we're probably going to have cassava mosaic disease because it is the vector for the disease. So, we can use data science to model and predict this phenomenon. And that is the beauty of data science in the field of enhancing resilience of people, communities, and systems. We can model phenomena that before we weren't able to, and allow people to know early on what to do so that they are resilient to system shocks. All right, let's move on to number three. Number three was protecting and enhancing natural resources. Now, this is uh, a very exciting area currently because the United Nations, well, pretty much the whole world is interested in protecting our ecosystems from deforestation and making sure that we still have a planet we can live in years from now when we have to leave it for our children to inherit. Well, data science plays a role here as well. First of all, we use it to monitor carbon stocks in natural and man-made forests. So if you are growing some trees, if your agriculture is tree-based, so you're doing some agroforestry, you're growing some rubber trees and all of that, or you are involved in carbon offsetting where you're growing trees and getting paid for it because you're offsetting some carbon emissions by somebody somewhere else, Uh, as you know, that there is that you can grow trees and get paid for reserving your land to capture carbon from the atmosphere. But people want to know if you actually grew the trees. And before, they would have had to visit your farm every single time and check that one, you really grew the trees, two, that the trees still exist 5 years later, that you didn't just plant them and next year you removed them to grow your cassava again. And we use data science to help us do that. We use drone-based LiDAR, uh, airborne LiDAR in planes, satellite interferometric synthetic aperture radar data, for example, optical satellites, for example. We use all these instruments to monitor where forests exist and how big they are. And from that, we can even monitor how much carbon is being kept in place because of the forests existing. And we can monitor how this changes over time. So, for example, if we take LiDAR data from a drone, we can monitor that the changes in the LiDAR signal over time and actually tell you how much biomass you are gaining every single day. And we can tell if that biomass stops, if that biomass gain stops, we can actually tell. We can tell if you've taken away your trees because we're able to monitor the biomass falling. So we use LiDAR to produce three-dimensional maps of your field and tell you exactly how tall your trees are. And because we know the species of tree that you say you grew, we're able to tell you how much carbon you're keeping and therefore give you the actual value of your forest, of your mini forest or woodlot, and pay you for it. How do we do that? It's a mixture of LiDAR and data science. And therefore, we are able to protect and enhance natural resources by being able to monitor how those natural resources are managed by using drone data, LiDAR data, and some clever data science. We can also do what is called monitoring, reporting, and verification for sustainable agriculture. And for this, we're able to actually use satellites like the Sentinel-1 satellite, which is an interferometric synthetic aperture radar satellite, or INSAR satellite, this term here, and some airborne LiDAR. We're able to tell if you tilled your land. So if you have cultivated your land recently, the satellites will tell us. We will know if you practice zero tillage or if you have actually started making ridges and using a plow on your land. As long as the soil is bare, we can tell after a few days if that soil is in the same state as it was last week or it has been disturbed, which is a signal that cultivation has taken place. So if you practice conservation agriculture, you will know that the first pillar of conservation agriculture is minimum tillage. So we're able to monitor if you actually practice minimum tillage. And the second one is permanent crop cover. So obviously we're able to tell from satellites if you actually have something green on your farm because we know plants are always green. Well, not always, but most certainly will mostly be green. So we're able to tell if you have permanent crop cover. And we're also able to tell if you rotate your crops because one of the things in conservation agriculture is crop rotation. And we can tell because we're able to classify exactly what crop you're growing. And we're able to tell when that surface of land has a new crop in it. So you can see that remote sensing and data science can tell us a lot of things. And we're able to also tell you how much, sorry for the typo here, how much soil carbon you have. And this is a mixture of weather data from NASA Power soil data from the likes of ISDA and others. We can use this to 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 inform soil carbon models like the Rothamsted soil carbon model. And all of that involves data science as well. So, as a summary, data scientists wrangle big data from remote sensing systems to engineer features that are useful for crop monitoring and for monitoring land use. And the majority of contemporary land use classification is actually based on machine learning, which is the core of data science these days. And the accuracy of machine learning models has become increasingly understood, such that people are now using machine learning outputs as inputs to mechanistic crop models that we used to use in the past. So things like Warforst or DSAT, all these crop models that you hear about, aquacrop, that predict how much you're going to harvest. Now you can start using machine learning based predictions of ground cover, for example, from a satellite to feed these models and predict how much we're going to harvest in a field. So it's quite an exciting field that you might want to consider for a career if you haven't done so already. And machine learning and data science will increasingly take up more space at the center of natural resource management. And this is the role of data science in protecting and enhancing natural resources. Finally, the last two are improving livelihoods, fostering inclusive economic growth, and the last one was adapting governance to new challenges. I put these two together because they sort of interplay and just also to save time. Um, Firstly, data science is everywhere in these two pillars. Data science is what informs access to markets these days. We have always had a problem in linking smallholder farmers with buyers, algorithms that link people that are looking for stuff and people that actually have stuff. Um, and these algorithms have now increasingly been related to data science. So we use data science to classify buyers and some clever, for example, matrix factorization algorithms to match buyers and sellers in a way that maximizes the chances of a business transaction taking place because we understand the buyer and we understand the seller quite well. And we know that this is a good match in terms of quality of produce, in terms of negotiation capabilities by the purse holder, for example. We use this to match buyers and sellers a lot. And as a result, you have so many apps these days that give you market information about the price of cassava in Edo State. I don't know. The price of cassava in Lagos versus in Ibadan. And if you're a cassava seller with a large batch of cassava, you can choose where to sell that based on how price is moving. And data science is what crunches those numbers to give you those figures in all the many apps that we use. This picture on the right is just some apps that I quickly Googled on the internet and found their logos and put them together and slapped them onto this slide. But all of these apps are doing one thing. They are um, well, maybe that's a generalization. They're not doing one thing, but some of these apps are linking buyers to sellers, which is what access to markets does. And most of these apps are actually agronomy applications that ask you questions about your farm, and then a machine learning model in the background tells you how much fertilizer to apply on your farm, or how which type of seed to use, what is the seed rate you should use. It's all a data science algorithm operating in the background. Uh, and also, governments are increasingly using data driven insights to make policy decisions. So people are no longer just going by the gut, like we like to call it. Uh, Decisions now in government are based on data mostly, and data science is the decision maker, really. It is the one that recommends what you should do because you use data science to arrive at the most optimal decision you can take as a policymaker. And impact assessment studies, more and more advanced data analytics is being used to assess impact on and off farm. So these are the roles of data science for improving livelihoods and in governance. So, as you can see, we've covered the five pillars. Um, this was a sort of whistle stop tour just to let you know what's out there. And data science is at the center of every single thing that we've discussed so far. Uh, what that means is data science is the contemporary method by which we make decisions. We make decisions based on data. We don't make decisions based on gut anymore. There are good things and bad things about that, but it's mostly good because you need evidence, you need accountability in the decisions you make. But just having data is not enough. Just having sensors is not enough. Just having big, fancy computers and gadgets is never enough. What you need behind it is data science, the ability to use that data to produce models that actually now speak to the questions that you're asking. They help you answer the questions that you've been asking when you started collecting the data in the first place. And therefore, the sensors and the data is the computer science part, it's the engineering part of data science. So having a drone, being able to take lots of images at the same time and using Pix4D or Open Drone Map or Agisoft, whatever it is that is used to bring these images together and produce an orthomosaic, the sort of stuff one does to generate a good drone image. That's the engineering bit. You've done the engineering, you've produced this big orthomosaic. Now a data scientist comes onto the scene and starts extracting information, like using a computer vision model to count how many plants there are in that picture, or using some mechanistic crop growth model to actually figure out the trajectory of crop growth based on that picture and other pictures from the past, or uh, use that data to tell you whether you're likely to have a fertilizer problem or not in that type of field. Those decisions take data science. They don't take um, anything else but you being able to understand what you need to do with the image data and produce the right output. And for you to know that, you need some statistical expertise. And that's where the statistics part of data science comes in. And you also need some subject matter expertise. You need to know what you're looking for. You are not going to produce a potato blight algorithm without knowing about potato blight. That's where data science becomes interdisciplinary, and any single one, it doesn't matter what degree you're doing, any single one has at least that subject matter expertise, any single one of you. And once you have that, all you need is the training in computer science and the training in statistics in order to be a data scientist. This is why this is an open career. Most people will only have one of the skills, but the other two you can earn in a relatively short amount of time. And hopefully that can make you better equipped to contribute to the goal of achieving sustainable agriculture in your household, in your county, in your district, in your country, in your continent, and in the world. But data science will be the backbone for this. So the last time we had such a uh, talk, I shared a slide about naysayers, and I thought I should repeat it with some updates. Uh, Data science used to be a fad. It used to be a passing trend years ago. It used to be, well, data science is just statistics. What's the difference? Oh, there is a difference. And that difference is nuanced, but it's big enough to make these two different fields. Because statistics is mostly focused on um, optimizing algorithms that reduce uncertainty in estimates when you have a model. But data science is mostly where you take these statistical concepts and apply them on big data. And you need a lot of compute to achieve that, but you also need a lot of subject matter expertise. Statisticians never needed to know anything about any field. All they know about is which statistical model to use when you have this experimental design. But to be a data scientist, you need to be an expert in something, and you need to understand how computing works, and you need also the statistical knowledge. So it's not a fad. It has a role in the world, and the role, hopefully, I have defined it for you and you can clearly see it. But this, when you hear such things, remember that it's always like that for a new field. In the 50s, there must have been somebody who would have said, we can do without electricity. In the 90s, there must have been somebody who would have said, we don't need all these connectivity with satellite TV and DSTV and instant news and all of that. I can do with my good old radio. But now everybody has a TV. In the 90s, somebody must have said, who needs a cell phone? I can't afford it. These days, the majority of people will have encountered or at least owned a cell phone, even in the remotest parts of Africa. You will never be too far away from a cell phone. In 2009, there must have been somebody saying the internet and smartphones are just pleasure technology. We don't need all of this. I don't need to be on Facebook all the time. I don't need Instagram all the time. Today, these social media have created many millionaires. People always are apprehensive about new ideas, new concepts, new technologies. And in 2018, I put there, somebody must have said, I don't need data science to tell me about my farm. Today, most, well, at least a good number of people will have encountered a mobile application that will tell them where to get which varieties and what variety should they put on their farm. Or when they go and talk to their extension agent, he will probably go on his phone and look up an app to give them an answer about what disease they are seeing in their field. All of a sudden, data science is no longer really something that we just talk about on the internet like this, but it's something that is being used to make decisions on a daily basis. Just last year, somebody would have said large language models and chat GPT are for the advanced people. Well, it used to be like that, not anymore. These technologies are now ubiquitous. They're being used in most of our lives now. You find it very hard to find a programmer, anybody learning computer science who isn't using a large language model, Gemini, ChatGPT, to sort of help them boost their productivity. And ISDA, for example, in Africa, is using a large language model to chat with you, to tell you how to grow your crops. Instead of you just interacting with an app, you literally talk to it just using WhatsApp. So these technologies will permeate into our lives, and you have to stay on the cutting edge in order to to stay afloat. Otherwise, 4 or 5 years from now, if you don't use data science in your work, you will struggle. So that's what I prepared. I hope it motivates you. And in closing, I can say if you haven't done it already, get started. There are many university programs in data science. Wherever you go on the face of the earth, there are many good programs and there are many shady programs and there are many bad programs. You have to look for the good ones. You have to look for programs that appeal to you. If you're an agricultural data scientist, try to stay within that field. Don't go working on um, um, acoustic data. Work on problems that appeal to you and appeal to the sort of people that you're going to serve. So you have to look for data science programs that align with your career trajectory. And for example, I put this up here because it's an option. I wanted to give you one of those options. At my university, we offer a data science postgraduate certificate, diploma, master's degree. It's data science for global agriculture, food, and environment. It's literally what we've been talking about. All of that. We teach that here, tailored towards agricultural professionals such as yourself, because that would be why you would attend a talk like this. So, this is something that would appeal to you. We have that at master's level. We also studying applied data science as a BSc. So these are the sort of programs that you can get in touch, for example, with our universities or with myself to talk about it if it's a career that you're inclined towards or interested in. It certainly is a career that is highly rewarding. Well, has rewarded me, I can say at least, and I can vouch for it. So uh, uh, should you be inclined to this, please get in touch. And the journey continues. So that's what I prepared. And thank you very much, Joseph. Back to you.
All right. Thank you so much, Doctor. It's really an interesting section with you. This is a worthwhile ride. You really give so much exposition and details to the concept of the topic. I also jot down so many informations here. I think this is part of what we send as an excerpt from each of the section. Yeah. Thank you so much. It's really great. So now, viewers, it's time for question and answer. So let me quickly drop that. So if you have question and answer, you can do all to drop them so that doctor can attend to them before he leaves the stage. So do what to drop a question. Any question you have so far on the concept of all what he has said as regarding the sensors, the equipment, the use of satellite data, pest infestation management. Also mention of the fact that data science technology and using computer vision technology, AI machine models could really give you things like early warning opportunities. So it quickly warn you to be able to take preventive measure in mitigating all of these things compared to when we're doing guesswork. Certain things you do not really know, you are not prepared for it because you are not even aware. But with technologies like this, you actually know how to run, how to navigate, and how to cope what is coming. So I think data science is very, very crucial in agriculture, especially when it comes to precision agriculture. And this is actually the future. So youth shouldn't just be amazed about using smartphone alone. So I think we really need to embrace the future. Yeah. I mean, Earth
Indeed.
observation technologies, and yeah, because for us to actually fast track productivity in what we are doing. So this is a very profound class. Thank you so much for those points.
Indeed. Yeah.
Yes, so if you have any question, please do well to drop them so I can bring them up. Or do you want to give your comment or station? So do well to drop them so I can bring them on board before we go. So if we don't have any question, then in the next five
Yep.
minutes, that means we have to call it a day. So I can
Yep.
leave here. So all
Indeed.
right. Okay, I have one question, sir. For people, you talked about data science, applied data science program. Is that going to be on at Upper Adams University? Is it an online training, or it's required to physically be on site to actually do this?
Um, a BSc is quite an undertaking. So most of it will be on site. We
Okay.
do have options for, especially the MSc. People can attend online, but they have to attend the session. So, there is online and online live. You can do an online course like the way most people go and do a boot camp on data science on the internet.
Yes.
It's not really conducive, and many people don't finish those courses. They'll get started and stop in the middle, and you can't really be certified like that. So we do have online options, but they're mostly online live. So
Okay.
you attend the class, but on the internet.
Yeah.
So there are
Okay.
those options as well. Yes.
All right. Okay. Thank you so much. All right. I just thought to ask maybe for some of our viewers who might want to ask that question. Or basically,
All right.
it's really good.
But
Okay. I'm
yes,
just gonna wait for like 3 minutes more. So if you don't have
yep,
any question, then you can. But
that's
thank you so
fine.
much for honoring our invitation. On behalf of the entire team at Christian Field Academy, Mr. Femi Adekoya as well, the vision lead. Yeah, I'm extending appreciation to you for joining and helping us facilitate the section. This is really profound and insightful.
Yes, so my contacts will be in the PowerPoint slide and the presentation. Anybody who watches the video later on and wants to get in touch, they are there. I'm
Yes, yes,
very
yes, yes.
keen to help, especially folks in Africa that need to be opened up to these opportunities. Please do reach out. Many people reached out to me the last time we had this talk in the previous edition of this, and I helped a few people there. So, if you have a question, if you need some guidance, if you need some mentorship, feel free to speak out and you shall be helped. So, yeah, thank you very much. Otherwise,
All right. Thank you so much, sir. I think I wanted to even ask your final notes before we close. But I think you've done justice to that already, and you encourage us and inspire us. Yes, data science is something very, very essential and crucial when it comes to smart agriculture. And people should actually reach out if they need help. That you are actually open to helping them. So that's fine. I did not get any questions so far. So that means we can actually call it a day. Thank you so much for coming, sir. So in case we have any other question later on, maybe from the group, I can always reach out to you and maybe get a response to them. So thank you
and
so much, sir. It's a pleasure to have you here. Do have a good day, sir. Bye.
thank you. Thank you very much. Bye.
Yes, sir. All right. Thanks everyone. Bye for now. So see you some other time.